Hello, calculus students and seekers of general truths. Let us conclude our study of complicated antiderivatives, at least what we've learned so far as being complicated, with an example where we kind of flip things around a little bit. So let's look at this scenario where this time, actually, if you notice, the denominator is simpler than the numerator. And I am not really sure if the numerator can be factored in any easy way. In fact, I'm pretty sure it can't. Okay, but regardless, how do we go about a problem like this? Well, let's consider our options. How about integration by substitution? Well, the derivative of the top is 4x plus 3, which is not a clean multiple of x plus 8 by any means, so that's going to get us into something that's a little bit messy. We can't try trig substitution, or we can't really do even integration by parts. At least if we do, it'll still get pretty darn messy. So let's go back to an old technique known as polynomial division. So we're just going to take 2x squared plus 3x minus 5 plus divided by x plus 8 and rewrite this after using polynomial division. Now, in this particular case, we have a monomial, or I'm sorry, a linear factor in the bottom here. So we could use synthetic division as well. Okay. Remember that synthetic division is a special case of polynomial division, and we happen to satisfy that special case. So let's see, synthetic division, you put a negative 8 here, put the coefficient here, 2x squared plus 3x minus 5, right? And then when we divide, bring down the 2, multiply by negative 8, you get negative 16, add them, negative 13, multiply negative 13 by negative 8, we get 104, and then add this, we get positive 99. Okay. And the result of this is really, this is 2x minus 13, and this is our remainder. Okay. I went through that quite quick. If you don't remember, please go how to do this. Please look at the old videos in pre-calculus on how to do synthetic division. Now, after we've done this, we can rewrite our antiderivative as follows. It's going to be the antiderivative of 2x minus 13 plus, right, the remainder over the divisor, x plus 8 dx. And I hope you can see and make the comparison here. The first expression, pretty messy to find the antiderivative. The second expression, significantly easier. So the antiderivative of this is going to be x squared minus 13x plus 99 times the natural log of the absolute value of x plus 8 plus a constant. All right, so there you have it, the conclusion of this lesson, and we end on something kind of surprising, which is rather than working with partial fractions to decompose them, when we have expression whose numerator is more complex than the denominator, and they're both polynomials, we can perform polynomial division. Sometimes we can do synthetic division and reduce the original problem into something that's a little bit easier for us to work with. As always, keep working hard, ask for help and clarification when you need it. Thank you for watching, and have a wonderful day.